Hello friends, I welcome you all to this session on C programming. So today we'll be learning about for loop and then we'll be solving these problems. So for loop is the most celebrated loop when it comes to uh, programming. Now previously you have seen while loop. While loop is basically entry control loop. That is, if the condition becomes false, so it will not enter into the while loop. And as well as we prefer while loop for the cases where we don't know in priori that how many times the loop has to run. Whereas for loop, we already know that how many times the loop must be running. So this is basically iteration control loop. So how many iterations you require, you run the loop for that particular iteration. So what is the basic syntax for it? The basic syntax is for, then you initialize it, then some condition is there, and then incrementation. Then comes the body of this for loop, that is the block of loop where we will be writing some of the statements. That's it. It is so simple. Initialize, condition, and then incrementation. So that is how we work with for loop. So let me show you that how this for loop works. Uh, so let me come to the code blocks and open some file. Let's say first one. Let us remove everything present inside. Now how to write a for loop? So basically for, then you initialize integer only. Remember. So can I write I assigned 0? Yes, I can do, but I have not declared it. So I have to declare it. So let's say I am declaring it here, that I is an integer which is starting with 0, and I condition, then comes condition I is, let's say the loop will run till I is less than, let's say 5. So loop will run for 5 times, that is 0, 1, 2, 3, and 4. The moment I become 5, it will stop. Then we have to do incrementation, that is I plus plus. That's it. So this is your for loop. So if you want to print the value of I in this case, so let's say I'm printing it in new line, and if I run it, then this is what the output will be. So I is 0, okay, then I becomes 1, then I becomes 2, then I becomes 3, then I becomes 4. So it will be checking. Then I will become 6, sorry 5, and as this is less than 5, so as the condition says run till, so execute this statement till it is less than 5. So the moment it becomes 6, it will come out of the program. So if I want to know that what is the value of I here, then it should come out as 6. Now one more thing, am I permitted to print the value of I here? So let me show this to you, and then we will be able to understand a very important property. It means the what we call it, the influence of a variable, or basically let me print it first. Percentage d comma I. Now let me write here also I. So if I run it, it is saying that I is undeclared. Why I is undeclared though I have declared this? So remember, whenever I am declaring any variable inside loop, the influence zone of that particular variable will be restricted to that loop only. And the moment the control comes out of that particular loop, the information of that variable will be removed from your stack. So if that is my program, let me snip this. If this is my program, okay, and now look very closely. So here, if we try to print I here at this point. What is happening? So when the command is inside the loop, so this is your main section, let's say this is your stack, so this variable I will be there. So the information of I will be existing till we are inside the loop. The moment control comes out, what will happen? This will vanish. There is no I inside. So the scope of this variable I is limited to the loop itself. And that's why when I say print I, it is not there. So remember, whenever I am declaring any variable inside a loop, then the scope of that particular variable will be restricted to that portion only. The moment control comes out, the information of that variable will be removed from stack. And the moment it vanishes, then what is I? Program doesn't know. So therefore, you should be very cautious, and this is a very beautiful thing, because here what I can do is I can use this variable I multiple times by limiting the scope of that particular variable. And let's say you want to make the scope of this variable for throughout the program, then what you do, you declare the variable outside this. So int I, the moment you say int I, what will happen? So the information will remain in the stack throughout this particular program. That means till it comes out. That means till you are executing the program. So till you are running the program, the information will be there. If I do this, if I declare the variable outside for, and now if I run it, look, I is 5 now. So the information of I is now available to me. Why? Because now I have made this variable, scope of this variable for the whole program. Now you should understand this very clearly. So that's all for the for loop. That is how we run a for loop. That is how we create a for loop. And there is no restriction as such. So let's say I'm starting at 1, okay, 10, and till I is, let's say, more than 5, this will run. Now what will happen? I is 10. I'm initializing, starting it with 10. Okay. And then if I increase, it will go to 11, it will go to 12, but it will always be more than 5. So if I run this program now, what will happen? This will go to infinity. Aha! Now we can make infinite program for loop also. So I can make this for loop infinite. Why? Because this condition will always remain true. So to terminate it, I have to use minus minus. So this is decrementation. So it will be starting at 10, then 9, and so on. So if I run it, so that is what will happen. 10, 9, 8, 7, 6, and the moment it becomes 5, it will come out. So that's why it is printing 5, because at this point the value of I is 5. So it is not at all hard and fast that you have to only use incrementation. You can use decrementation as well. So let us head to the program which we were planning to write. The program was write a program to find the factorial of a number. So before we write a program, we should have that number. Okay. So let's say n. I'm giving it here. I'm not writing printf, scanf, those things. You can do it yourself. So let's say 5 is the number whose factorial I'm interested in. Then, for factorial, you have to repeatedly multiply it. So let's say f is the variable where I am repeatedly multiplying and storing that value and initializing it with 1. Okay, I am interested in finding out the factorial 5. So the program, the counter start with 1. It will end when this I become exactly equal to 5. And then for everything I have to increment it. Then inside what I have to do? I have to supply the value of f times I to f. Okay. So we have to assign f times I to f. So first, what is the value of I? It is 1. What is the value of f? It is 1. So what will be printed? 1. So let me do this here. Let me bring this print statement inside. And what has to be printed, as well as f has to be printed. So tab and then f as percentage d. So here let me print f and then bring everything to the new line after this is executed. So now if I run this, oh, what has happened? It is already running. Okay, so if I run this, so it will do this. When I is 1, so f is 1. When I becomes 2, so f will be 1 into 2, that is 2. When I becomes 3, so this will be 2 into 3, that is 6. When I becomes 4, it will be 4 into 6, that is 24. When I becomes 5, it is 24 into 5, that is 120. And then I becomes 6. But the condition says run the loop till it is equal to 5. So therefore it will come out of the loop. So in this way you can print the factorial. So come out, simply write the uh, percentage d factorial is nothing but percentage d. In the first case n will come, in the second case f will come. So 5 factorial is 120. Similarly, let's say I am going to this number, that is 4, so it is 120 again. Why? Can you tell me? Okay, this is very interesting. I am writing 4 factorial and it is giving me 120. Why? Just because of this 5. Yes, you are right. This has to be generalized. This has to be till n. So now if I run it, so it will give me 24. So these are the mistakes which normally people do while creating a program. And this happens when we are not thinking in terms of a general number. When we are thinking in terms of a specific number, then this happens. Okay, so that is how you create a program for finding the factorial of a number using for loop. Then what? Then comes the second one. Write a program to find the exponent, that is a to the power b. What is a to the power b? So if I am interested in writing or finding out 2 to the power 3, what is 2 to the power 3? It is 2 times 2 times 2. That means whatsoever the power will be, that this number will be multiplied that many times. Okay. So if it is 2 to the power 4, then this is 2 times 2 times 2 times 2. How many times? 4 times. So how to write it? Very simple. We have to multiply it to 4 times. What we have to count? We have to count that how many times it has multiplied. That's it. So let us head to that code blocks. So let us say my A is 2 and B is, let's say, 3. Okay. And then I will be requiring that product. Let's say it is F only, doesn't matter. Then what I have to do? If you look here, first it is 2 times 1, then it is 2 times 1 times 2, then it is continuously being multiplied. So for I this, it is going up to what number? It is going up to that B. Okay, very good. And then what I have to do? I have to continuously multiply I. No, continuously multiply A. So first, so let us print it here. What is happening? I is percentage D and that F is percentage D, and in place of I will come, and then here F will be printing. So let us, so if you run, oh, I have to bring this to new line. So if you run it, so what happens? When I is 1, F is 2. Okay, when I is 2, then this will be 2 into 2, that is 4. When I is 3, this will be 4. Sorry, when I is 1, it is 2. When I is 2, it is 2 into 2, that is 4. When I is 3, it is 4 into 2, that is 8. So that's why you are getting your answer. So what we have to do? We have to bring this out. Okay, so we simply say that A, let's say I am using this for power, this is equal to this. So first A will come, then B will come, and then that product F will come. So if you run it, so you will be getting 2 to the power 3 is 8. Don't consider this as bitwise right now. This is just symbolic for the power only. So likewise, if I make this 3, so that is 27, 9 3s are 27. So in this way, you can create a program for exponentiation also. Now what is the third program? The third program is write a program to print all the prime numbers between 1 to n. So now prime number, you have already done it. Okay. So how to write it? So first you should have some number that till this number I want the prime. So let's say it is 15. So till 15 I want the prime. Okay. So you know when a number is prime if that particular number is exactly divisible by two terms only. Okay. So now inside what you have to do, think in this fashion that what you have to do. You will be taking one number, let's say I is 1. Then your program should say that it is not a prime number, so it will not print. Then 2, it is a prime number, it should print. So program should know in priori that how to find out the prime number. And you have already developed that logic previously, that if I start dividing a number by numbers from 2 to that, and if that happens, if that particular number, the numbers by which that number is divided, if that comes out to be exactly 2 in number, that means one is 1, another one is that number, then that is what we call as prime number, otherwise not. So the question says print all the primes. Then inside, look what we have to do. We have to run a loop. We have to divide by that I every time, because what I mean to say is, look here, I'll start with certain number, let's say I is initially 1, so I1 is not prime, then I will be starting with 2, so the I will now become 2. Now we have to check whether this is prime. So what I have to do, we have to run again a loop. So for I uh, equal to 1 to that number, I exactly equal to, so less than equal to 2 here, and then I plus plus. So what will happen? So the thing which is happening is I have to check that if I remainder, that is sorry, if, then I have to change the variable also inside this particular loop. So let us do it and let us see how it can be done. So consider another loop. So for int j assigned, it will be starting with 1. J is less than equal to I, and then j plus plus. Now this is basically loop inside loop. Okay, so I'm starting with this. I have to check up to this n. Forget about this right now, and make this I here itself. That means declare here itself. Now what we have to do? What we have to do? Look, if uh, I I percentage j is equal to 0, that means it divides. Okay, then what I have to do? I have to make one counter here. So int count, let's say it is 0. So if this is happening, then simply say count plus assigned 1. So this will do what? This will take one number I, this number j. So if j will go from 1 to that number, and it will start dividing. And if that divides, then counter will increase by 1. Okay, now what I have to do outside this, if if the count is exactly equal to 2, then what I have to do, I have to print that number. That's it. That means, let us do what? Let us bring this print here. Then I have to print that number. What is that number? I have to print I, that is my prime number. So That is how the logic works. Let us see whether program runs or not. So there is a problem. What is the problem? It says, okay, so it should be semicolon, not comma, because that is a statement in itself. So again, there is a problem. Can you tell me why this is happening? This is happening. Yes, this is happening because of this semicolon also. So what are primes? 2, 3, 5, 7, 11, 13. Oh, they all are prime. Congratulations. Now you developed a program in which you have used nested loop. That means loop inside loop. And this is not a very big deal. What we have done, we have taken one number. I have started dividing from 1 to that number. I have counted, and if that count becomes, so I have counted what divisions, how many j's are dividing that I. So if that count becomes 2, okay, then print that that particular I is prime. Otherwise, don't do anything. Simply go to next I value and then again do the division. So in this way, this program will work. And if you are still having difficulty in understanding this, you do what? You remove everything. You run one loop, I, and inside that you run another loop, j, and that will go up to I. So that, and then print inside that j, print I and j. Then you will be able to see first I is 1, okay, then j will be 1. Then I is 2, so j will be 1 and 2. Then I is 3, so j will be 1, 2 and 3, and so on. Even what you can do is you can also convert the same program for this particular prime with slight tweaking to convert it into a program which can print beautiful patterns also. Okay, so here the logic is very simple. Let me write the logic here. Let's say I am having numbers like I as 1, 2, 3, 4, and so on. What is happening? I am checking first. So inside that j loop is doing what? That is checking that whether it is divisible from 1 to 1. So as this is only a one number, so this is not prime. Then here it will be dividing by 1, then it will be dividing by 2. So the j loop will run 2 times. And here it will be dividing by 1, it will be dividing by 2, and it will be dividing by 3. So now it will run 3 times. So for this it will run 4 times, 1, 2, 3, and 4. So for every increasing number, the j loop will run that many I times. Okay. So in this way it will check. And what it will do? It will do this. So if in this case it is coming out as count as 2, so it will print. So here it is only divisible by 3, these two. So again it will print that 3 is prime. Here it is divisible by 1, and it is divisible by 2, and it is divisible by 4. So it is number. So how, what is the count right now? It is 3. So it will not print 4. So in this way this program works. So friends, now you know that how to use your for loop to solve problems. Now what we'll be doing in the next class is we will be taking some challenge in a sense that we will be trying to solve some basic engineering problem with the help of these loops. Okay, so get ready for that particular lecture, because there you will be learning that how to integrate, how to implement integration into your program. So in this lecture till this point only, in the next lecture we'll be doing that. Thank you very much. Take care.